Welcome to a walkthrough of the Wednesday version of the second exam for Philosophy 120 in 2020. Let's jump right in. The distinction between primary and secondary qualities raises some really deep and interesting philosophical issues, which didn't really come out as much as I might have hoped in some of these answers. A lot of you just appealed to an unexplained notion of what it is for something to be real. This is somewhat understandable, and you got significant partial credit, but I'd like to try to show you how these issues are a little more sophisticated than your answers let on. So, primary qualities do not depend on any facts about an observer. They are features of objects that the objects have, as it were, in and of themselves. Some examples would be mass, shape, motion. Secondary qualities depend for their existence on an observer. So, color, sound in the sense of perceived pitch, though not necessarily in the sense of vibrations in a medium. So the thing I want to get across is the relations between this distinction and reality are pretty complicated. Buicks or Subarus depend for their existence on human beings, but that doesn't make them unreal. So it's not the case that Galileo and Descartes thought that secondary qualities were made up or utterly unreal. They just weren't real in the sense that their Aristotelian opponents thought they were real. They were not external features of the world in the same way that primary qualities are. So that's the heart of the distinction. You needed, in order to get full credit, to show me that you understood that primary qualities do not depend for their existence on there being a second thing, as it were, an observer, whereas secondary qualities do. But that doesn't mean we're just sort of painting colors onto the world. It means secondary qualities are a product of interactions between external objects and their primary qualities on the one hand, and our sensory apparatus and our minds on the other. All right, the second one, you need to understand the problem you're trying to solve. I got a lot of really irrelevant answers to this one. So you need to understand the objection to the Copernican view that was that it posited two centers of motion. So on the Copernican view, everything goes around the sun except for the moon, which goes around the earth. Whereas on the Ptolemaic view, everything goes around the earth, the moon, the sun, the planets, the fixed stars. And so having two centers of motion rather than one looks like a significant weakness in the Copernican view. A lot of you just threw out some telescopic observation of Galileo's, but one that didn't really bear on this issue at all. The observation that bore on it was the observation of Jupiter's four, at the time, moons. Those were how many Galileo could see with his telescope. And the way in which that bears on the issue is now everybody is stuck with multiple centers of motion. Jupiter's moons go around Jupiter. So even on the Ptolemaic view, you've got more than one center of motion, so it's no longer a particularly strong objection to the Copernican view that it posits multiple centers of motion. Number 3 raises some deep issues. A number of you, I think, maybe didn't understand the question particularly well. So the clockwork metaphor is a metaphor for a mechanical model of the universe. And in a certain sense, Newton represents a culmination of that model, and in another sense, he represents kind of an abandonment, or at least a walking back of that model. The heart of the issue concerns gravity. So, is gravity a mechanical force? Well, yes and no. It is a force that operates at a distance and isn't teleological in any obvious sense, so it meets some of Kepler's desiderata for the clockwork model, but Newton had no mechanism for it. He had no explanation of how something as far away from the Earth as the moon could pull on the Earth and vice versa. And so it's a little like Kepler's clockwork, but also like Kepler's model of the solar system, where he posits a force without providing any mechanism for how the force operates. So this is something I hope you will take away from this course: the ways in which we have a mechanical understanding of the universe are complicated because the notion of a mechanism is a complicated notion. As we get to Einstein, we will see a more mechanically sound conception of gravity. Briefly explain Descartes' argument that there could be no such thing as a void or vacuum. He really gives two different arguments, and you could have gotten full credit with either one if you presented it accurately. The one most of you chose was the argument that says if there is literally nothing between two things, then they are literally touching. The idea that two things can be separated by nothing at all is a sort of implicit contradiction, according to Descartes. The other way of getting there is what it is to be a thing is to take up space. And so the idea of space without a thing in it is itself a contradictory idea. You need to present Hume's counterfactual analysis of causation. That is one of his two analyses of causation. He thought they were equivalent, but nobody else thinks they're equivalent. So you couldn't just throw out some stuff Hume had to say about causation. The counterfactual analysis competes with the regularity analysis. The regularity analysis says that to say that A caused B is to say A-type events are always followed by B-type events. That's not the analysis you're concerned with here. You need to be specific enough to distinguish the counterfactual analysis from the regularity one. The counterfactual analysis says A causes B whenever, if A hadn't happened, B wouldn't have happened. You need to bring in what English professors call the subjunctive mood there. If A had not happened, B would not have happened. Why does this have some surprising consequences? Well, if Jones eats a pound of arsenic but is fatally struck by a bus, then had he not eaten the arsenic, he still would have died. Had he not been hit by the bus, he still would have died. So initially it looks like neither the arsenic nor the bus killed him. That's weird because it looks like he died and that death was caused. This was not your problem on my exam, but a more sophisticated counterfactual analysis would more precisely describe the event in question. And so you can make the arsenic the cause of his death if you say Jones would not have died at the time he did or in the manner he did. So you'd have to pick out the event in a more sophisticated way. Corpuscularianism is the genus. Atomism is a species of that genus. Most of the philosophers we read, philosophers including here physicists, of the 17th century are corpuscularians. That is, they explain observation in terms of matter in motion. Atomism is that flavor of corpuscularianism which adds to generic corpuscularianism the denial of a void or vacuum. Not very many of you brought that up. And the idea of indivisible bits of matter. Indivisible, sorry. It's hard to talk and spell at the same time. So Descartes is a corpuscularian, but not an atomist. He denies that there could be a void, and he denies that there are indivisible bits of matter. All right, you needed to explain Leibniz's relationism about space and time, not just state it. I tried to make that really clear. So relationism says that space and time have the metaphysical status of relations or relationships, not of things. You may or may not have cousins, but cousinhood is not a thing. Likewise, space is not a thing for Leibniz. It is a way of talking about distances. Time is not a thing. It is a way of talking about relations of preceding, succeeding, or being simultaneous with. So, for him, it's not that space and time are utterly unreal, but they are not things. They have the status of something like convenience in a convenience store, which is not a noun, but depending on how you formulate it, something more like an adverb or an adjective. Not unreal, but not thingy. The biggest problem his view faces is it might not make space thingy enough. It's fine to say that, but you got to explain what you mean. You got to show me that you understand what you are saying. The worry is Leibniz doesn't make any clear room for the existence of times where nothing happens or places where nothing is. So if we're just talking about relationships of distance, how can we make sense of a relationship of distance between two not things? Leibniz solves that by saying we can talk about possible distances. So we can talk about what it would be for there to be another star halfway between our sun and Alpha Centauri. So there's nothing there, but we can make sense of the closest thing we can to empty space by saying if there were another star there, here's the distance it would be from, say, Earth. The worry is that might push Leibniz too far in Newton's direction. Newton's rejoinder to that is to say, if we're going to countenance possible places where something could be, possible times when something could happen, then you're basically thingifying space and time. You're talking about a feature of the universe that something could be located at in space or in time. And so it's hard for Leibniz to allow for possible distances and durations without slipping pretty close to Newton's substantivalism. Newton's absolutism, which is another name for substantivalism, does thingify space and time, but it doesn't really give them any features or properties. Space is an utterly empty, propertyless thing that has stuff, in some sense, in it. We talked about the weirdness of that in. Likewise, time marches on even if nothing happens, even if it can't be detected by change. And that's the biggest problem Newton's view faces, as Leibniz pointed out. Leibniz says there can be no scientific facts that are in principle unascertainable. And so the location of something in absolute space is unascertainable, because if God were to move everything 1,000 miles in one direction with respect to absolute space, things would look exactly as they do now. If God were to have made the universe 1,000 years earlier or later with respect to absolute time, things would look exactly as they do now. And so Leibniz says there is no there. There can be no, in principle, unascertainable scientific facts. Newton responds to that by distinguishing between motion at constant velocity and accelerated motion. If you've looked at the stuff about general relativity, you see that this distinction looms large in our course. Newton says acceleration, which includes deceleration, with respect to absolute space, does have observable consequences. You feel forces when you suddenly come to a stop or suddenly start moving with respect to space its bad self. That is not a conclusive argument. If you slam on the brakes of your car, you definitely feel forces, and you are definitely decelerating with respect to something, but it's not clear that it's absolute space. It could be the Earth, it could be the center of gravity of the Milky Way galaxy. There are lots of different answers. It gets complicated and fancy. I didn't expect you to go too deep into things. I didn't care whether you want to decide with Leibniz or Newton. Both have sophisticated and problematic positions. As always, when I ask questions like this, I'm asking you to show me how clearly and effectively you understand the view in question. All right, last one. Newton's inductivism and his rejection of hypotheses. Newton says science is about noting precise, quantitatively ascertainable patterns in experience and generalizing them as far as we can, as far as the world will let us. His rejection of hypotheses concerns attempts to work out things like the nature of matter or motion in advance before doing experimentation. That's Descartes' conception of hypotheses. He also rejects Huygens. We didn't read Huygens this go around, but we talked about him. Conception of hypotheses, which is much more Popperian and much more contemporary, where we form guesses about things and then we test our guesses. Newton doesn't like either one of those things. He likes experimental quantitative detection of patterns and inductive generalization of those patterns. So we describe experience, we go beyond it by projecting patterns, but we don't try to go behind the scenes. We just rest content with nesting our generalizations within one another and using that to explain stuff. So Hume is a Newtonian. He's an inductivist. Not only do we have only patterns and experience to go on when doing science, but all our ideas derive from experience. We don't mean anything by an idea unless we can trace it to its origins and experience. So the idea of a unicorn, we can understand by saying we combine the idea of a horse, the idea of a horn, the idea of whiteness, that kind of stuff. But for an idea to be legitimate, you have to show where it arises in experience. And he denies that we have any experience of causal necessity. We observe one thing happening after another, but we do not observe anything causing or making something else happen. All you observe is the cue ball going from point A to point B. Sorry about my dog. The 8-ball going from point B to point C, and you hear a sound. You do not experience any causation. So it looks, initially anyway, like we can't even meaningfully talk about causation. We'll get back to where we get our ability to talk about that in a second. Why is this argument read as supporting a Newtonian approach? I tried to go into that in some detail. I think it's important. I was pretty disappointed in this aspect of answers to the question. What Hume tries to do is make contact forces as mysterious as Newtonian gravity is. So, yeah, we don't understand how the moon and the earth pull on each other without a rope, but we also don't understand how billiard balls move each other. Hume is trying to revise and make more modest our conception of what it is to understand something. All we can do is go back to the most basic patterns and experience and say, as far as we can tell, this is what always happens. And so his skepticism about causal necessity supports a Newtonian approach to scientific explanation, because he says all we can do is make inductive generalizations. It seems to be the case that whenever a cue ball touches an 8-ball, it always moves. What makes it move? We have no idea. What makes it the case that the Earth and the Moon pull on each other? We have no idea. So I think you get a deeper understanding of both Hume and Newton if you bring them together, and not very many people succeeded in doing so. Much more specifically, and this part was also a little disappointing, where do we get our idea of causal necessity? Hume doesn't say it's nonsense, which is what it looks like he should say if it can't be traced to experience at all. This is where we invoked Pavlov's dogs. His answer is, we are compelled, we are made to think of the 8-ball moving whenever we think of the cue ball touching it. And so the necessity is internal. It is a necessary connection between our ideas, not between objects in the world. And so we can legitimately talk about causal necessity, but we are projecting something that happens inside our heads out onto the world. Hume's skepticism about induction says that it is utterly without rational justification to think that the sun is going to come up tomorrow. It's not enough to say we can't prove it. That fundamentally misunderstands Hume's point. So his view is, it is no more reasonable to believe the sun will come up tomorrow than it is to believe the sun won't come up tomorrow. Induction and counterinduction are equally unreasonable. That doesn't mean you shouldn't believe the sun is going to come up tomorrow. It means you shouldn't believe you are reasonable in believing it. So we are not fully reasonable creatures. We're not nearly as rational as we like to think we are. And so it's a good thing that the world pushes our buttons and compels us to take certain patterns seriously and to use them to guide our action. Otherwise, we'd starve to death. But that's not being reasonable. That's being pushed around by the world. We're no more reasonable than Pavlov's dogs or Bertrand Russell's chicken. It's just that it's a good thing we're not reasonable. So we couldn't stop believing the sun will come up tomorrow. So we should recognize it's without rational foundation. Then we should happily go about believing those things, even though they're without rational foundation. Hopefully this answers most of your questions about how you lost points, or it will once I give you your exams next week. If you have any questions after you've looked at your exam and watched this walkthrough, by all means, please contact me. Thanks as always for your time and attention.